In a certain species of mammals, gray fur, big G, is dominant to white fur, little g, and brown eyes, big B, are dominant to blue eyes, little b. A male with genotype big G, little b, is crossed with a female with genotype little g, little b. What portion of the offspring would be expected to be heterozygous for both traits? So the first thing I want to do is make sure I understand what genotypes I'm working with. It tells me that the male has genotype big G, big B, little b. He's heterozygous for both traits. And it tells me that the female is homozygous recessive for both traits, little g, little b. So knowing the genotypes of both parents, I can now make my Punnett squares. Because I'm looking at two traits, I'll make two Punnett squares. My first Punnett square is going to be about fur color. So I've got big G in the male and little g in the female. So now I'll fill it in. My second Punnett square is going to be about eye color. The male is heterozygous and the female is homozygous recessive. And now I can fill that in. So let's look at our question. It wants to know what portion of the offspring will be heterozygous for both traits. Well, looking at my first Punnett square, I can see that 1/2, 2 out of 4, which is a half, of the offspring will be heterozygous for fur color. Looking at my second Punnett square, I can see that 1/2 of the offspring, 2 out of the 4 boxes, which is a half, will be heterozygous for eye color. Now, remember, we don't just look at these and go, oh, a half and a half, so the answer is a half. In order to find the final answer, I have to take whatever the fraction or percentage I get from each Punnett square and multiply them together. You always have to multiply the number from both Punnett squares. So multiplying my numerators, 1 times 1 equals 1, and 2 times 2 equals 4 for my denominator, and I can see that 1/4 of the offspring would be expected to be heterozygous for both traits, making the correct answer A.